Yes, dear students, in last video, before starting the topic of surface tension, I discussed with you the internal forces in liquids, the nature of and origin of the force between molecules of liquid. And I told it is van der Waals force, and which arises due to induced dipole moment or dipole already present like H2O, HCl. Now, their intermolecular forces are of two types. Number one, cohesive forces. The force of attraction between or among the molecules of same material is called cohesive force. For example, intermolecular force in water molecules is cohesive. Intermolecular force between mercury molecule cohesive. And due to this cohesive, for example, force between two molecules of water or molecules of liquid like mercury are called cohesive forces. Due to cohesive forces, small drops of mercury are spherical. It is due to cohesive forces between the molecules, the small drops of liquid like water and mercury are spherical. The spherical nature of these drops can also be other way also, but ultimate reason is the intermolecular force. Now I come to adhesive force, number 2. Adhesive forces. Adhesive. It is called adhesive, yes. Adhesive forces. Actually, before telling any phenomena, we need not lot of knowledge. Actually, to define surface tension, I have read So many books. So many books. अरे please. To explain phenomena of surface tension, we need so many things, and I have read many books, and different books are explaining in different way. But ultimate cause of that is intermolecular force. Intermolecular force. So now I told that forces between the molecules of same type of material like water, mercury is coercive. Now adhesive force. The force of attraction. Force of attraction between molecules of different materials is called adhesive. Dear children, try to learn physics, not mathematics or physics. That is required also, but first of all, we should be very clear about physics of the topic, adhesive forces. Now you may ask where it is there. Adhesive force between water molecules and molecules of container in which water is poured is more than coercive force between water molecules. That is why water sticks to the wall of container. Generally, a question is asked why water wets the walls of container, mercury does not. You can read your book. It is given there. Here the sea force between adhesive force between glass and water molecule is more than coercive force between water molecule. So water molecule get stick to the walls of container and wet it. While mercury, in case of mercury and glass or any type of container, mercury may be filled any container, but force of attraction, coercive force between mercury molecules is greater than that of adhesive force between glass and mercury molecules. We use many adhesive. These paints done on wall have much adhesive force greater than force of attraction between the paint. This chalk I have written here on the board. The adhesive force between the molecules of chalk and board is greater than the coercive force between these chalk molecules. I hope you have got it. Simple introduction is there. And due to this reason, if we fill water here, it may concave surface. Water may concave surface because water get stick to the and it attracted by the container. Water filled here is attracted by the molecules of glass, and so it rises up and a concave surface formed. If you fill mercury molecules have greater coercive force than adhesive between container and molecule of mercury. So it forms a concave surface here. Mercury, this is the region of this curved surfaces. You might have seen in your chemistry lab when you fill up a solution in burette concave surfaces are seen, or you can see at home if you fill up water in tumbler near the walls of tumbler, water is little above the free surface. So this was all about. There are many reasons. You may be asked here, a small drop of mercury is spherical, but bigger drop is flat. If here I have a small drop, it is spherical for mercury. But if it is a big drop, it is spherical. Why? Because in this case only cohesive force is in action. Here, because of large mass, the weight also action, and this cohesive force is much less than weight, so it gets flat. If it is a big drop of mercury, it becomes flat because weight mg also come into action. Mg weight, and surface tension means that cohesive force between mercury molecule is unable to overcome this weight. Here cohesive force greater than mg, so that can overcome this weight, and thus it may remain spherical. Now I come to the main topic, surface tension. Surface tension. Am I? There are lot of examples I have explained now which prove that surface remain under tension. Why? Because of intermolecular force. Actually, I told you in last video, molecules on surface of liquid have greater potential energy, and to reduce the potential energy, the molecule have to be attracted by molecules below it, and liquid surface tends to decrease surface to reduce potential energy. Some people explain that way also. So surface of liquid remain under tension, and that is why you can see if we put a needle on blotting paper and then leave the blotting paper on water surface पर हमने blotting छोड़ा and with a needle. After some time, this blotting paper absorb water, gets sink, but needle keep on floating. Needle iron nail should not be very heavy. It's small, lighter nails keep on floating, not due to buoyant force, because of surface tension. Hair of painting brush, when dipped in water, get stick together because water molecules attract and they it get stick together. So many examples are there. So surface of liquid remain under tension. Then how to measure? Now consider here a surface. Suppose it is any surface, regular, and here it is liquid surface. Don't think it is the upper surface. Don't think that liquid is filled up. It is surface of water. Now if we imagine a line on this surface, so this line divides the surface of water into two, and it appears that the either surface on the two sides of line, imaginary line, these two surfaces pull each other. This surface pull this one like this one like this. So this force by which the surface on the two sides attract each other is called surface tension. How it is measured? So you can write here, let in figure we have considered considered an imaginary line, say PQ, line PQ. It has been noticed that thus liquid surfaces on either side of imaginary line pull that liquid surfaces on either side of imaginary line pull each other by force F. This pulling force per unit length of imaginary line this pulling force per unit imaginary line length of imaginary line is called is the measure of surface tension. So if capital F be the magnitude of force on length L of imaginary line on the surface of liquid. Then surface tension of liquid is given by I write here T equal to F by L. T equal to F upon L. Force per unit length of imaginary line. Its unit simple है. The unit of surface tension is Newton per meter. Dimensional formula for T is equal to M L0 T minus 2. Secondly, I want to tell you surface tension of a liquid decreases with the increase of temperature of liquid, and also decreases with impurity added to it. That is why in winter season we wash clothes with hot water, and soap also is impurity added, and that decrease the surface tension, and due to reduced surface tension, liquid molecule can penetrate through small hole of cloth and can wet. Actually, it is the water which brings the dirt out of the surface. It is the water which brings the dirt out of. Maximum cleaning action is due to water molecules attract the dirt. So it is little about surface tension. I try to explain you in terms of energy as well as other factors. But the result of all is force, surface tension, force point length. Because when force is there, work done appears the form of energy, potential energy or kinetic energy. We will meet in next video with other topic.